We're going to try our hand at a word problem. So this is our problem. Suppose the temperature starts at 60 degrees and raises 2 degrees Fahrenheit every hour. Use a table, an equation, and a graph to describe the relationship between the amount of time that has passed in hours and the temperature. So we're going to be comparing amount of time in hours and the temperature. So we need to know that we're going to start at 60 degrees. And every hour it raises 2 degrees. So let's make our table. So we're going to do a table. I'm going to label it table. And then what do I have? I'm going to have X, which I'll call my input. And what is that? That's going to be my time. And then I'm going to have my function. What happens? We're going to do that kind of special. And then we're going to do our Y, which is our output. And that's going to be our final temperature. Okay, so let's go ahead and we'll just go ahead and put our columns in here just to keep ourselves straight. So we're going to start at time 0. So at time 0, we're starting when? Time 0, we have no function that's happened yet, but we know we have 60 degrees. So in 1 hour, what do we have? We have 60 degrees plus 2 degrees, which is what? That is 62 degrees. In 2 hours, we would have this number, which is 62 degrees plus 2 degrees, which gives us 64 degrees. 3 hours, we have 64 degrees plus 2 degrees, which gives us 66 degrees. Let's do one more, because we're actually looking for a pattern. Then in 4 hours, we have 66 degrees plus 2 degrees, which gives us 68 degrees. Okay, so that's showing the relationship between time and temperature in a table, but it's not helping us too much with the equation. We've done this, but it's really not in a form where we can write an equation. So let's think about what's happening here, and I'll try to explain this as best I can. So, what did we do here? First we started off with 60, and then we added 2 and got 62. So the question is, let's rewrite this number 62. So instead of writing 62, didn't we get 62 by adding 60 plus 2? So that means 62. Let's rewrite 62 to be 60 plus 2, okay, and then we have this plus 2. Okay, so how did we get 64? Well, 64 we got from doing 62 plus 2, but I wrote 62 to be 60 plus 2. So instead of 64, it's going to be 60 plus 2 plus 2. That equals 64, right? So here I'm going to write 64 as 60 plus 2 plus 2. That was this line. And then I have this plus 2 that I'm adding on. So that gives me 66. So what I'm doing here is this is becoming my 64. Right? So that there is my 64. So how do I write 66? Well, I'm going to write 66 to be 60 plus 2 plus 2 plus 2, right? Because isn't that what 66 was? 60 plus 2 plus 2 plus 2 Okay, so that there, this here is the same as 66, but I still have this plus 2 at the end, plus 2. So now it looks like we have a pattern. So notice how my 60 is always 60, yes? So 60 is always consistent. So I know that my equation is going to be 60 plus something, okay? Because that 60 is the same. You notice here I have a 60. Notice here I have a 60, and here I have a 60, and here I have a 60. So 60 is always the same. Okay. But what's happening? Here I'm adding 2. Here I'm adding 2 2's. Here I'm adding 3 2's. And here I'm adding 4 2's. So I'm adding 1 2. Well, look, here's number 1. So isn't this 1 times 2? Here I'm adding 2 twice. Isn't that the same as 2 times 2? Here I'm adding I'm adding 2 3 times. Isn't that the same as 3 times 2? And here I'm adding 2 4 times. So isn't that the same as 4 times 2? So remember, this is what's changing, right? So isn't that represented by x? So this number here, this here is my x value when x is 0, when x is 1, when x is 2, when x is 3, when x is 4. So my x is what's changing, and that's going to be times 2. So that's really my expression. So let's rewrite that. That's going to be 60 plus 2x. And that's going to give me my output, which is y. Or I could rewrite this to be y is equal to 2x plus 60. Okay, and we're going to see why I wrote it like that later on when we start graphing. So the next thing I need to do is I need to graph. So my time, this here, is my independent variable, and this here is my dependent. So when I go to graph this, I see here that I'm starting at 60 and going up. My time starts at 0 and is going up. So I'm actually going to use this little space down here. So I'm going to go ahead and just make my XY axis over here to the side. And I'm just going to plot some points. I only need to be what's called the first quadrant because it doesn't make any sense to have any negative time, although I could have negative temperature. So I'm going to make this time 0 right here, and then I'm going to do every other one. So this here's 1, this here's 2, this here's 3, this here's 4. Okay? So I'm starting at 60. So if I do, let me see, if I do 10, this would be 10, 20, 30, 40, 50, 60. So this here is going to be, if I did that, that would be 60. But let's do, well, maybe we'll do that. I'm going to make this 60. Then that would be 70, correct? So the problem with using the scale that I'm using right now is that it's too close together. Since these here are going up every 2, let's do this. We're going to do this thing, we're going to do like a jagged line here. Jagged line. That means I skipped a whole lot of stuff. I'm like skipping that area, crunching it down. So let's start this with 60. This was 62, 64, 66, 68, and 70. Okay, that worked out quite nicely. So at time 0, I have 60 degrees. So at time 0, I'm right here at 60 degrees. At time 1 hour, I'm at 62. So at 1 hour, I'm at 62. At 2 hours, I'm at 64. At 3 hours, I'm at 66. At 4 hours, I'm at 68. And we could continue. We would know at 5 hours I'm going to be at 70. And we can do what's called extrapolation and figure out how that goes. So, because I could have a temperature at the half hour, I could have a temperature at somewhere in between 1 and 2, I can actually draw a continuous line. So at time 0, I'm at 60. And this can go up like that. Okay. Now granted, in real life it's not going to go up forever, at least we hope not. But so now what I've done is I've shown the relationship in a table, I've shown the relationship as an equation, and I've shown the relationship as a graph. In fact, this equation here is the equation of this line, and we'll be investigating that in future lessons.